In this video, we're going to discuss some of the basic arithmetic operations that exist in ARM assembly. In addition to discussing these, we're also going to discuss a few different modifications to these instructions that tend to be present in a lot of the instructions in ARM assembly. And they allow us to do very interesting things like setting the CPSR register after the instruction is run. And the reason why we're going to discuss these first with arithmetic instructions is because arithmetic is easy. Everyone sort of knows about adding and subtracting and multiplying, so it's a very easy sort of place for us to work with these instructions. Once we get a basic understanding of these instructions, we'll take on some of the more interesting and complex constructions, allowing us to be able to discuss these ideas with a solid understanding and foundation already in place. So to start off with the very basics, we can add, subtract, and multiply numbers in ARM using a set of instructions. So the first is add, the second is subtract, and the third is multiply. Now you'll notice that division isn't included in this. Division turns out to be a fair bit more complicated than the other three instructions, so it requires a little bit more finesse to get it working. So we aren't going to discuss any division, we'll discuss addition, subtraction, and multiplication. So when we want to add two numbers together, for instance, it's fairly straightforward to do. What I'm going to do is I'm going to move some data into some registers. So we'll add some, we'll put some numbers into these registers. And then we can use our add operation. Our add operation is going to take in a destination and two sources. So the destination for this is going to be R2. And then I'm going to add together two numbers. So I'm going to add together R0 and R1. And what this is going to do is it's basically going to do this. It's going to put into R2 the result of R0 plus R1. So that's all this is really going to do for us. So it's just going to add the two numbers together and store the result in R2. So that's nice and easy. Let's just take a look at how this works just to get comfortable with it. So I compile and load. You see I can load 5 into register 0, 7 into register 1. I add those two together and I get C, which is equal to 12. So 5 plus 7 equals 12, so we can see that the addition instruction works successfully. So that's the way that addition works for us. And the other instructions work very similarly. I can change this to sub, and what that will do is it will do the result R2 equals R0 minus R1. And then we can also do multiply. And what that will do is it will do R0 times R1. The main thing to keep in mind here is that R0 is always the first operand, and then R1 is always the second operand, which only really matters in subtraction, right? In addition and multiplication, the order doesn't really matter, but in subtraction, it does, right? And you can see that when we take 5 and subtract it from 7 in this example here, we would clearly get a negative number, right? We'd get -2 as our result. And that's where the interesting ideas start to come in with our arithmetic operations. So if I were to do this right now, we can see that I get 5 and 7, and when I subtract them, I get this big number here, or this big looking number here. And when I convert this to decimal signed, you can see I get -2, right? But if we're looking at it in hexadecimal, it isn't really necessarily clear. Because the reason why it's not necessarily clear is because we could have had a very large number in R0, and maybe a small number in R1, and when I subtract them, I would get potentially this very large number here. So the question is this a very large number, or is it a negative number? There's some overlap there, right? Because of the way that we store negative numbers in assembly, we don't necessarily know right off the bat if this is a negative number. I mean, I clearly know now because I put in 5 and 7, and I know that subtracting those two gives me a negative number, but think for a minute if we had, say, a user input and we subtracted two numbers that the user gave us. How do we know if they gave us a very large number or a negative number, right? How do we know the difference between those? And just to sort of maybe drive this point home, I'll just show you what I mean by it could have been a very large number. If I were to put this as a hex, right? So I can say, let's say 1, 2, 3, 4, 5, 6, 7, 8. So we'll do all F's like that. And then I would have to subtract 1 from that, right? And we'll just change around this ordering so that it's the first one. Well, actually, no, we can keep it like that because we want to do R0 minus R1. So what I mean by it could have been a large number is when I have this result here and I subtract it from this number here, you see the result is the exact same, right? We get this all F's and then the E at the end. So you can see if I take this big number and subtract 1 from it, I get this. But also, if I take 5 and I subtract it from 7, like we did before, we get the same results. So this is why there's the question of, well, is it a negative number or is it a very large number subtracted from a very small number? And the way that we solve this problem is using the CPSR register, which is this register right here. You'll notice some of these letters along here, the N, the Z, the C, V, I, all these sort of letters. Each of these indicate a specific flag that is set in this register. The N, for instance, stands for negative, so it will tell you if the result of the last operation was a negative number. And that's exactly what we want, right? We want to set that flag so that we can understand that this result is negative. And it can do other things too. It can take care of if there was a carry in the operation, if there was an overflow, if the result was 0, and that sort of idea there. So how do we get that to actually set? Because if you notice, when I compile and load this and I step through these instructions, nothing happens to the CPSR register. The answer is that we have to use a special type of instruction called in this case, I'll call it an arithmetic with flags. And the way that it's represented is we just add an S to the end of our instructions, so sub S in this case. So sub S is going to set the flags in the CPSR register. And you might be thinking, well, why doesn't it just always do this? Why doesn't the subtraction operation just always set the CPSR register? And the answer is because to set the CPSR register requires at least one additional operation, right? It requires us to actually load data into that register. And that, adds a little bit of overhead to the operation. If we don't need to do that, then we shouldn't. So that's why there's two separate instructions for this, because one of them is slightly more efficient than the other, and slight efficiencies do matter when you're programming at such a low level. So then the second question that you might ask is, well, when should I use sub S over sub? And the answer is you should use sub S if 1, you know that there's going to be negative numbers, or 2, you don't know what the values that are going to be subtracted are. That means you're loading them from some location that you don't have control over. If you're just taking two constant numbers and subtracting them from each other and you know what the result is going to be, then you can use, whatever instruction is appropriate. If it's going to be positive, just use sub, that's okay. If you don't know, then you should use sub S, so you can check to see if it's positive or negative. So just to demonstrate what this ends up doing, when I compile and load this, like I said before, when we do this, now you see that this CPSR register has changed. And you can see that N is now bolded. That means that it has identified that the result was a negative number rather than a positive one. And that's exactly what we were looking for. Now, just to note, the reason why this bit is set to 8 is because so each of the 4 bits at the beginning of the CPSR register stands for one of the flags, and that's the same with every bit. Every single bit is one of the flags. So since it's set to 1, 0, 0, 0, that means the negative is set to 1, which means that it was negative. And then I think that the other 3 zeros are the 0, the carry, and the overflow, which are all set to 0. And that's why they're grayed out here. So that's the way that those flags are actually set. So if you're not working in an emulator, you'll just see that set as 8 rather than seeing the N highlighted. The N being highlighted is nice for when you're learning because obviously that tells you, hey, it's a negative number. But if you're doing this just like on like a Linux system or something like that, you won't see that. You'll just see the 8 instead. So it's good to understand exactly what that's doing as well. So that would be the idea of our arithmetic operations. Now, there's one other additional arithmetic operation that is quite helpful for us, and it's the fact that when we add two numbers together, in some instances, you might end up with a carry. And basically what that means is that the number was way too big to actually be stored inside of a single register. So to give you an example, if you have like, something like this, and you want to add it to maybe something like this, right? So we'll just say, we'll add this. And this is another example where you would want to use something that actually sets the flags. And the reason being is because when you do this addition, you'll notice that when you add these numbers together, it's far too big to actually be stored in one register because it overflows beyond 32 bits, right? So you'll see when you do this, it actually sets the carry flag in here to indicate that there was a carry that happened in this operation. So these are the sorts of operations where you would end up with potentially a carry, right? So when these sorts of things happen, we want to be able to catch them, as we did here, but we may also want to use that carry at some point later on. So if we want to add a carry operation, then what we need to do is we need to use the ADC operation. What this will do is it will add a carry to a result. And what I mean by that is basically, so if we were doing this this operation here, the result would be R2 equals R0 plus R1 plus the carry. So the carry will basically be a 1 if this flag is set equal to 1, or it will be a 0 otherwise. So that's the way that this works. So it's either set to 0 if the carry is not set, or it's set to 1 if the carry flag is set. So that's the way that this ADC operation works. And there are other ones as well, so we can subtract as well using the same sort of idea. We can also multiply with the carry, but the most common one would be the add, which would be ADC like this. So this gives you an idea of some of the fundamental arithmetic operations, and we'll see these as we discuss other assembly programs, but this just gets you familiarized with how we add, subtract, and multiply numbers, and some of the little quirks of setting flags when we do these different types of operations.